Good morning, everyone. Yes, so I'll be talking about ENS. I am the co-founder and the CEO of Unruggable, and I'll be talking about building the verified web. The term Web3 was coined by Gavin Wood. And he said Web3 is a decentralized online ecosystem based on blockchain. And when asked exactly what is Web3, he said less trust, more truth. And I started to think that it might be necessary to have a new term to describe a slightly different internet. And the reason why is because the internet is about to undergo a shift from largely user-generated content to more so AI-generated content and AI agents. And this will probably take place in the next couple of years where we'll actually have more agents, more AI-generated content than human-generated content. And I think many people have predicted that there will be a major problem, and that is we won't really even know who the users are on the internet anymore. We won't know what the content is on the internet anymore. And so started to think that it might actually be necessary to have a verification or a proof on every single interaction. And I looked a little bit at this idea of what's called the Internet of Proofs, or also the verifiable web. Sergey of Chainlink talks about the verifiable web. He also talks about this problem of AI agents and synthetic content. And I just thought I would see what ChatGPT said. And I thought it actually came up with a pretty good definition. It says the verified web is an evolving internet paradigm where trust is built into digital interactions through verifiable cryptographic proofs, allowing users to engage securely and confidently with authenticated content and services. The verified web is an evolution of every web that's come before it. And it's not an internet that is, say, you could imagine a agent-to-agent internet where everything happens opaquely. I think it's very important that we maintain the human-readable quality of the web. I started to think about the principles that might build this type of new web. And I think the first one that's very important is that it's human-readable. We don't want to have an internet, like I said, that's opaque to humans, even as agents start to take on more agency and more of the lion's share of the traffic. And I think, for instance, in OpenAI came out recently with their operator, and you have this interaction where you can see what the agent is doing, and I think this is very important to be able to observe what the agents are doing, actually start to be able to learn, and the internet should still be human-centric. With the verified web, the core idea is that there should be verifiability in all the interactions that take place. So we need to have verified users. We need to have verified online content. Self-custody must always be possible. And I think the distinction here is because I think a lot of users are not just going to always use self-custody, but it should be possible. For instance, within Coinbase, you can move your funds in and out. And I think that should be a distinction in the verified web. Then in terms of decentralization, I think it should be continuously moving forward. I think we can see that basically Web 1 was more decentralized than Web 2. So I think we need to try to avoid that and always move decentralization forward, largely in step with the decentralization of blockchains and the space generally. And then we have to worry about platform risk. I think this is something that just should be improved about the internet in general. When thinking about the verified web, I thought, okay, what is the core technologies that go into the verified web? And I would start with cryptography. It plays much more emphasis on the idea of cryptography, and particularly, I think that ZK proofs are going to play a much bigger role moving forward with the verified web. And then we have tokenization. Tokenization, I think a lot of times you'll see people that talk about, where are the apps with blockchain? And I think the answer is that we have a killer app, and that's tokenization. Sort of like email, like it was invented, it works, it still works today. And I think it's true with tokenization as well. It's just going to continue growing. Tokenizing everything is say, killer app of blockchain. And then, of course, cryptography is one of the pillars. And then we also have decentralized storage. Basically, it's kind of like data liveness. If we're going to be able to prove our content, we're going to have access to it. And the question is, do we want to move away from centralized actors to more decentralized? And then we have ENS. ENS sometimes is thought of more of as a project. It's a way to take your wallet address and be able to have a user-friendly name. But I think of ENS more as a platform. And it's actually been growing a lot recently. We've looking at, particularly through name services like Linnea and Uni and Base. These are all added hundreds of thousands of names to ENS, and actually you can see that it's in the last 2 years, all this growth has happened, largely because of a technology that was introduced called CCIP read, or 3668, ERC 3668, which allows for the idea of starting on layer 1 and then going to layer 2, or to say off-chain. And the only issue with that is that in this list of names, there's only one that's actually still on blockchain and also fully proven, and that's Linnea. They've actually created a system where you go from layer 1 to layer 2, and they have a fully proven end-to-end system, whereas Base and Uni are still off-chain, or Base is actually on-chain, but it's used as a trusted gateway. And this gets into a little bit of the work that we've been doing at Unruggable. We built Unruggable gateways last year, and this complements CCIP read. And the way that it works is CCIP read is basically the protocol or the standard that allows you to go from mainnet to layer 2, but the actual standard for the proving is Unruggable gateways. And Unruggable gateways basically takes the data that you get from an L2 and brings it back to L1 and actually verifies the data in a standard way that works across many blockchains. Here's basically how it works. The client, which is a wallet, would initiate a resolution request. It would go to layer 1, and then it would check, and if it doesn't exist, the name doesn't exist on layer 1, then it would redirect to a gateway, which would check the layer 2, and then the layer 2 would actually, the client would actually retrieve the data from the layer 2. ENS generally works, its sort of killer use case in the last few years has been to create a on-chain profile. And this idea of having a universal profile is also sort of an important idea in the verified web, because we know that currently with profiles we have the idea that you set one up on every single service or every single app. Like you have your Gmail and you have your Yahoo, and then the question is, how do you connect all these together? And it's a big mess. So I think most people think that you should have one profile. It should be cryptographic. It should be on-chain. And ENS actually works pretty well for that. But I think there's a mental framework that we can have. And the mental framework basically is things a user says about themselves and things that can be said about the user. And right now, ENS is pretty good at creating a profile about things that a user says about themselves. And that is like their avatar record, it's their addresses, their wallet addresses. They can also have text records. And these are all records that they can change at any time. But if we focus more just so on the things that things that can be said about a user, we have a whole world of data that starts to come about associated with the user. And those are things like credentials. So if we imagine that you get a university degree, and when you get the university degree, the institution signs your transcript. So you have all this information about yourself from the university. And then let's say you also have a passport, which has all the information about where you've traveled, about your residency. And then let's say you want to add something to your credential, your profile, and that is basically to say, I would like to tell people that I have a university degree and that I've lived outside the country in a foreign country for more than a month. And this is something that you would actually like to communicate about yourself and have as a proven credential. And then that's where ZK comes in, because ZK basically you can think of it as a way to do compute over signed data, and also has this privacy-preserving property. Base names have a similar system where they have this like badge system, and I think this is maybe a way that people could imagine building these rich data credentials, profiles. In this case, they have this idea of an online builder score. Well, it's a builder score that actually can be put on chain. This is the talent protocol that they work with, and it sort of looks at the history of your wallet activity, and it starts to build this score. Currently, this protocol exists within Base or within Base Name's website, and it doesn't actually travel with the ENS name. So one of the big challenges we have with ENS profiles is the idea of having a universal profile that travels anywhere across any chain and is uniform. So basically, what is possible is this idea of having specific protocol level features for each of the different profiles. So this is the base names, and it could have its own, let's say, base IPs, base name IPs, that could say, okay, we have this builder score, and we'll include this as a text record. In this case, it's eth.base.builderscore, and this would be able to be embedded directly into the ENS name and travel when a person uses their base name on a different chain, say Optimism. But what this really necessitates is, well, let me just go back. For that sort of thing to happen, it's actually currently not sort of possible or very difficult at the moment. And the reason why is a few things. So number one, we have the problem of a uneven security property for all of the different types of ENS names. So originally we had L1 names for ENS, and L1 names have a uniform security property, and that is basically vitalik.eth. It's on L1, we know where it's being resolved from, but as soon as we bring in all these other name services, we actually have this unequal security property. For instance, uni.eth names, their subnames, they're actually just running off of a server. I assume they'll move it to Unichain in the future, but right now it's just a trusted server that allows you to resolve the name. So we don't have a good sense of what all these names, their security properties are. The other problem we have is the fact that every ENS name has a resolver, and that resolver can be changed by the user at any time. So if there are these on-chain records that are wired up to check an on-chain record or check an attestation on the ENS name, if the user is able to change the resolver at any time, they can actually spoof the record. So that's another issue. And then I think the final issue, which is another big issue, is that because you have this direct wiring between the client and the layer one, you often have clients that are either out of sync, you have libraries that are out of sync, and you have these uneven implementations of ENS. And as a person in the ENS community, I often find it frustrating that every single DApp I go to or wallet actually implements ENS differently. So what we're currently working on at Unruggable is building this new layer, calling the metadata layer, and that would basically help the client, say the wallet, to understand the security properties of each of the ENS name services, and it would also provide this kind of locking functionality. The locking functionality basically is a heads up to the client that would say, this resolver has been changed in the last 30 days, this resolver has no audits, but if it's a service that the client is happy with, the wallet is happy with, it would kind of say the opposite. It would say this resolver's lasted a long time, it has audits, and then the clients really get to decide how which names they resolve and which names they don't resolve, or they could show warnings. There's just a lot more that they can do, and it provides this ability to provide ZK-based attestations and ZK and just on-chain data in general as part of the traveling ENS records. Okay, I ended a little early, but anyhow, so I guess we can open it up for questions.